Day 397 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3362, zero array transformation 3. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n and a 2D array queries where queries of I equals li, ri. Each query's I represents the following action on nums. Decrement the value at each index in the range li and ri in nums by at most once. The amount by which the value is decremented can be chosen independently for each index. A zero array is an array with all its elements equal to 0. Return the maximum number of elements that can be removed from queries such that nums can still be converted to a zero array using the remaining queries. If it is not possible to convert nums to a zero array, return -1. All right, y'all, so I can understand how that can be difficult to understand. So let's go ahead and take a look at these examples to make sure that we're doing this question correctly. So in example 1, we have the input nums equals an array of integers 2, 0, and 2. Queries, 2, 0, and 2. Queries equals an array of a 2D array of integers, that first array being 0 and 2, second array being 0 and 2, third array being 1 and 1. The output is 1. Explanation says, after removing queries 2, nums can be converted to a zero array. Using query 0, decrement nums 0 and nums 2 by 1 and nums 1 by 0. Using queries 1, decrement nums 0 and nums 2 by 1 and nums 1 by 0. All right, y'all, so even that may be still a little bit confusing at first glance. So let's go ahead and break this example down one step further. So first thing I'm gonna do is I'm gonna copy and paste this over here just so I could give y'all a better visual representation of what is going on. Boom. So we have the input nums. Our goal is to make nums an array of all zeros, right? So let's just say goal is for nums to equal 0, 0, 0, and 0. That's our goal, right? This is our goal right here. Now, how are we going to achieve this goal? Boom. So we have these queries. These queries let us know that each index, so these queries represent an index in nums, right? So this query represents index 0 and 2, right? So this index and this index. This query represents index 0 and 2 as well. So this index and this index again. And this query represents index 1 and 1, which would just be this index. Boom. So what we want to do is each one of these indexes we're allowed to decrement by at most 1, right? It says decrement the value of each index in the range L of I, Ri, and nums by at most 1. So with this being 0 and 2, that means, with this being 0 and 2, that means we can decrement this index by 1, or at most 1, and this index by 1. Index 0 and index 2 we're allowed to decrement by at most 1. So let's do that. Let's come over here. When we nums equals, we decrement this by 1, so now we're at 1, 0, 1. Boom, because this says we can decrement this by 1 and this by 1. Now we have this query. Same thing, 0 and 1. We're allowed to decrement it. Now we can decrement this by 1 and this by 1. Index 0 and index 2. So we do it again. We say nums equal, then we have this array. We decrement index 0 by 1 and index 1 by 1. So when we decrement this by 1, we get 0. Then we don't have to do anything to this, so that can stay 0. Then this, we decrement this by 1. Boom. It says at most 1, so sometimes we don't have to decrement anything. So boom, decrement that by 1. So now we have our 0 array, which is what we wanted. That was our goal, right? That was the goal. Nums equals 0, 0. That's our goal. We did it with these two queries, which means we can remove one query. That's why the output is 1, because this query we don't need. We can remove this query right here. It says return the maximum number of elements that can be removed from queries such that nums1 can still be converted to a 0 array using the remaining queries. So we can remove this element or this query right here, boom, and still have these queries are still enough to get us to our goal of a 0 array. Now, we're just returning the number of queries we have to remove, right? So it's just one. We're not returning the query itself, but that's how we got the answer 1, because all we had to do was remove this one query right here. And so our output is 1 because we only had to remove one query. So just in case that didn't make sense, let's go ahead and take a look at example 2. Example 2 is the same principles. We can get rid of this. Oh, sorry, y'all. I don't know what's going on with that. We can get rid of this. I'm going to copy and paste this over here again, just so for a better visual representation for y'all. So we can put nums here. This time we have 4 queries. Boom. So we could put queries here. So example 2, we have our input nums equals an array of integers 1, 1, 1, and 1. Queries equals a 2D array of integers 1 and 3. Second array being 0 and 2, third array being 1 and 3, and the last array being 1 and 2. This time the output is 2. It says we can remove queries 2 and queries 3. So let's go through that so we can make it make sense. So first we have queries 1 or we have our first query, which is 1 and 3, which means we can decrement index 1 and index 3 by 1. So after we do that, we'll have nums equals, nums equals, then we have 1, but we decrement index 1 by 1, so that's this one. So we have 1, 0, comma, 1, comma, and we decrement index 3 by 1, so that's this one. So that would become 0 as well. Boom. Now we're moving on to this query, 0 and 2. So this query says decrement 0, index 0, and index 2 by 1. So what that would be, boom, so we have nums equals, then we come to index 0, we can decrement this by 1, that'll give us 0. Boom, then this is already 0. Boom, then it says decrement index 2 by 0, which is this right here, so that becomes 0 as well. And then we already have a 0 at all, so boom, we have a 0 array, which is our goal. In this case, it'd be 4 zeros, but we've reached our goal right here with just these 2 queries, which means we can remove these 2 remaining queries. Boom, that's 2 queries that we can remove, queries 2 and queries 3. And when they say queries 2 and queries 3, they're talking about the index. So this is query 0, index 0. This is queries 1. This is queries 1 right here at index 1. This query is query 2, and this is queries 3, right? We can remove 2 and 3, boom, and we're left with just these 2, which will still allow us to get our 0 array. But since we can remove 2 queries, our output is 2, because those are 2 queries that we can remove and still achieve our goal of getting our 0 array. Boom. So let's take a look at example 3, where example 3 is kind of it's tricky, but it's not really tricky. It's just an example where it's impossible to get a 0 array, so we have to return -1. So in example 3, we have the input nums equals an array of integers 1, 2, 3, and 4. Queries equals a 2D array with only one query or one array, 0 and 3. Output is -1. Explanation says nums cannot be converted to a 0 array even after using all of the queries. So once again, we'll copy and paste this over here just so we could go through it. Boom. Now all we have is one query. It says we can remove at indexes 0 and 3. So we come right here, nums, we remove, we decrement 0. At index 0, we decrement by 1, so that becomes 0. Then we have 2, this is index 1. Then we have 3 at index 2. Then we have 4 at index 3. We can decrement it by 1, so that means we'd have 3 right here. But that's our only query. So in the end, this is the best we can do, right? We have 1, 0. right? But we want all zeros. So since it's impossible for us to make this a all zero array because we can't even touch these two middle numbers right here, then our output is just going to be -1 because it's impossible. So boom, that's how this works. When it's impossible to do, we just return -1, such in this case. So that's why the output is -1. So I hope that made sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult, so let's get started. Now, the first thing we're going to do is we're going to get nums.count. So we're going to say let n equal nums.count. Then we're going to do the same thing for queries. We're going to say let m equal queries.count. Boom. Now we need to sort the queries by the left endpoint or the start index in ascending order, and each query is going to be represented as a left and right. So for that, we'll say let queries equal queries dot sorted, open up the brackets. We're going to say $0, open up the brackets, 0. Then we're going to say the less than sign, should be a $1, square bracket, 0. Boom. Then we're going to come underneath this and we are going to create a max heap to store all available queries by their right end, and we're going to start from the current index. So we're going to say var available heap, and we're just going to set that equal to a heap. Then we're going to say less than and greater than, put the parentheses, and this is going to store queries and indices and behave as a max heap. Then we need a min heap to track the queries that are currently active and being used. So we're going to say var active heap. We're going to set that equal to a heap as well. We're going to do the same thing. We're going to say less than and greater than, put the parentheses, and this is going to store the end indices of currently used queries as a min heap. Then we need to keep count of how many queries are currently active. So we're going to come right here, declare a variable called operations. We're going to set that equal to 0. Boom. Now we need a pointer to iterate through the sorted query. So we're going to declare a variable called j, set that equal to 0. Then we're going to say for I in 0 ... less than sign n. We're going to open up the brackets and we're going to insert all of the queries that start at index I into the available heap. So we're going to say while j is less than m and two and signs queries square bracket j square bracket 0 equals I. We're going to open up the brackets and we're going to say available heap dot insert, open up the parentheses, queries square bracket j, come outside of that, square bracket 1. Then we're going to come underneath that and we're going to say j plus equals 1, just like that. Now the number of operations we need to keep track of the number of operations needed at index I. So we're going to come underneath this while loop and we're going to say let need equal nums square bracket I. Now, if the current number requires more operations than currently active, we're going to try to activate more queries from the available heaps. So, or from the available heap. So for that, we're going to say, we're going to come underneath this let, and we're going to say while need is greater than operations, we're going to open up the brackets and we're going to try to get the query with the maximum right bound that can still cover index I. So we're going to say guard let query available heap dot pop max parentheses comma query is greater than or equal to I, else we're going to open up the brackets and we're going to return -1. So if no such query exists, it's impossible to satisfy the requirements. That's why we're returning -1 right there. Now we need to activate the query by adding it to the active heap. So we're going to come underneath this guard statement right here, and we're going to say operations plus equals 1, come underneath that, active heap dot insert, open up the parentheses, query, just like that. Now we're going to come underneath this, we're going to come right here underneath this while loop, and we're going to start another while loop which will deactivate any queries that are no longer valid and their end is less than or equal to the current index. So we're going to say while let min equals active heap dot min comma min is less than or equal to I. Then we're going to open up the bracket and we're going to say active heap dot remove min parentheses, we're going to say operations minus equals 1. Boom. And now we need to return the number of queries left unused in the available heap. So for that, we just come right here and we can say return available heap dot count. Just like that, y'all. That should be all she wrote. Let's go ahead and give it a run. Make sure it runs before we submit it. Okay, so sorry. So this should be for IN, not for NN. Let's see. Okay, we have another one, another error. Guard expected else after guard. We got the else. Hold on now, y'all. Oh, maybe it's this right here. Well, that should be need. I don't know if that's gonna fix it, but I mean that needs to be fixed. Let's run it, see if that fixed it. Nope. So while sorry y'all, should be an equal sign right here. Now let's run it and see if that works. Let's see, and it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how this LeetCode stuff can be. Ooh, look at that. 56 milliseconds beats 26.21% of users. We can definitely get those numbers up. But don't worry, we just want to be able to solve the problem that is presented to us. And I feel like this is a good solution for that. Easy to understand, where we'll be able to retain the knowledge and use the knowledge that we've retained in future LeetCode problems. So with that being said, y'all, make sure y'all get one more look at the code. This is the top part. This is the middle part. In case you didn't get that. Boom. And then this is the rest of it. And with that being said, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.